card.
You guys are up early this morning.
Yeah.
Only a little.
Should we wait for maybe 5 minutes in case somebody?
Yeah, in case Matthew should
Yeah,
look up.
that's okay.
If he doesn't respond on
Let me pick this.
oh yeah, do your thing. We have one other member, Matthew. If he doesn't respond on Slack in the next 1 or 2 minutes, we're probably good to get going. He warned us ahead of time that waking up early may not be his strong suit. But fortunately me and Abel will hopefully be able to get everything rolling.
Okay, you're back.
I'm back. Did I cut out there for a sec?
Yeah, there's one of our internets is not real fast, I think.
Most likely ours, knowing Stanford's connectivity these days, but let's hope it holds. If it doesn't, we can always try and see if we can move to a different location and get it as good as clear as possible for you.
Okay, so is Matthew a team member or a flyer of record or both?
He's our team member. So there's two Matthews. There's a Matthew Tan, and then there's also Matthew Wynn. Matthew Wynn is one of our team leaders and sub-team leads specifically for recovery, and he handles most of our simulations as well. And he'll probably be able to be the best mind to answer some of those questions or concerns. Abel has some experience with that as well. And then I do here and there. So we'll answer as best as we can, but hopefully Matthew would be able to give you a little bit better response.
Okay, and what's your name?
My name's Max. Max County, yes.
All right. So how do you want to proceed? Do you have a little presentation or something, or?
Matthew is rolling up. Abel's also rolling up just now. She had to run and go grab something. I think she potentially had a plan for kind of how we wanted to display some of our information. I'm not 100% sure. So hopefully. Hey Abel, what's our plan? How do we want to kind of display some information and such?
Yeah.
Yes, if we had a presentation.
We have the technical report. Do you think it will be better if we share screen and then you can ask on any section?
Okay, for whatever reason, they don't let the safety reviewers see the technical reports. I'm not sure why that is, so I have not seen it. So
Oh, okay.
Would we want to pull up the poster?
Oh,
That's only on AV though.
no, the poster.
The poster. It has everything.
Wait, so you're not allowed to see the technical report, am I right?
well, I don't know if I'm not allowed, but they don't arrange for the links so that I can see it.
I think we can share screen. So I don't see why not. Okay, I'm gonna share screen the technical report if that's okay with you.
That's fine. Yeah, if you just want to kind of walk through some of the features and then hopefully you've got a rocket there with you and we can take a look at the rocket.
Yeah, we have the rocket.
Okay. So yeah, it's whatever you want to show me is fine. Most teams have been just sort of walking through a few slides and then, just doing a tour of the rocket.
Okay, I will be sharing screen. Yeah. So yeah, our project is basically a 2-stage for 30K COTS, and it's going to be 13.18 feet tall and 4 inches in diameter. And this is the system architecture overview of the fully integrated rocket.
Okay, and I think I've seen this drawing.
Yeah, I think we uploaded it in the interim report.
Yeah, remind me, your payload is fixed? And there, you're not deploying a payload?
Yeah, it's fixed. It will stay inside.
Okay. Okay,
Yeah, and we will use an N3300R and M1600R for each stage corresponding.
okay, and that's CTI for the 3300?
Both of those are Aerotechs.
They're both Aerotech, okay. And do you have them in your possession?
Yep.
Yeah,
Okay, and are you gonna go ahead and dry fit everything or assemble before you come to New Mexico?
we will bring all the motors with us, and I think we will assemble in New Mexico.
Say again?
We will assemble it in New Mexico.
Okay, but you'll dry fit it ahead of time, all right?
Oh yeah.
Yeah, definitely do that because you often will have to shorten the liner or make some other adjustment in order to get it put together. And you want to avoid those surprises in
Yeah.
New Mexico and make sure that you have everything that you need to put it together and that it all fits.
Okay, yes. And yeah, we just have a few simulations. One sec. Wait, this is not the latest one. I think I have a. If you go to, I should really honestly.
I have the other one pulled up on
Here, you can display only the PDF if you press on the, will you click on this?
This?
Yeah.
Click to hide
Oh,
video.
wait,
Click to
I
show
think
video.
this one.
This
Actually,
one.
you can hide the code. Yeah, that's what I have.
Okay, yeah. It's just mostly the same thing, but okay. Yeah, so this is just the flight profile of the rocket.
Okay, so yeah, usually the only part of it I care about is the lower left hand 1 square inch.
Okay.
Yeah, so let's see. Yeah, that timing looks okay in terms of the amount of delay time. Looks like you're lighting the, well, we'll go over the timing for the staging at some point.
Yeah. Okay. And then this is a picture of the rocket. We also have it with us if you want to see it in person. Well, it's downstairs, but yeah. So this is the picture of the rocket. And staging mechanism is 3 events: activation signal at target velocity or apogee, and then stage separation and forward motor ignition and aft descent.
Okay, so just a moment. So I'm not quite sure I understand the order. Normally you would separate the stages first and then signal the igniter. So it's like the event 1 and 2 are backwards.
Yeah, this might be just poor phrasing. Activation signal would be in terms of the actual staging activation, the black powder charge ignition, or I guess the E-match rather than the actual ignition of the motor. So the event one refers to we are meeting our flight conditions to safely stage. And with those flight conditions met, we send a signal for the E-match to ignite, lighting the black powder charge for staging. And then that third event would be the forward motor ignition.
Okay, I think I understand that. Now, let me ask you, I sent a recommendation for how to program the Blue Raven for staging. Did you receive that?
Was it with the interim report?
I sent you an email. That had, it was something like, recommended two-stage staging program.
Oh, and Hero X is an announcement.
Yeah, I'm not sure it's Hero X, but it's the ESRA email. However you received those from me.
Yeah. I'm trying to look for it right now. But oh. Okay, yes, I see the email to two-stage teams. You recommended that you keep the time window that the sustainer can be lit as short as possible.
Yeah, that's the email. And in the case of the Blue Raven, which I think you're using for staging,
Yes.
yeah, you can set up the you know a I think they call it a custom program for the altimeter for the Blue Raven to do what it is that's outlined in that email.
Yeah, okay.
So you don't use the air start default in the Blue Raven.
Yeah, because in our test launches, we use the stage separation, burnout count, and 0.5 seconds after conditions met delay.
Okay. Yeah, I'm not sure about stage separation, but there's a, you know, in like the third channel, you can select, well, I think you can select almost anything, but you know,
Yeah.
main deploy or drogue deploy or air start or whatever. And so there's a default program in there for air start,
Okay, yeah.
but don't use that. You want to set it up as a custom program following what's written in the email.
Okay. Okay, yeah, we will definitely look into this and compare it with the one that we're currently using and see which one is more safer and works better.
Yeah, and you know, contact me if you have any questions on what the program is for. If you want to do something else, you can, but you'll have to fight with me on why it is that you want to do that.
Yeah, okay.
And I'll probably point out how come there's a better way to do it. But that's sort of the default way of doing staging when the altimeter has the capability to select the time and the altitude criteria that we want to use. So let me know if you have any questions there. On the Blue Raven, for the stage separation, now you're going to be using a black powder charge to separate the stages,
Yes,
right?
sir.
And then shortly after that, you'll have something that then lights the sustainer motor.
Yes, sir.
Okay, so the criteria for stage separation is much looser than for ignition because you want stage separation to happen. So usually the only criteria that you use for stage separation is some amount of time after burnout or after launch. And that's about it. You know, you wouldn't use like a tilt criteria or much else because, you know, no matter what happens with the lighting the igniter, you want the stages to separate so that the recovery is not interfered with. So, at some point in time, I'll just ask you to show me, some screenshots of the program that you're using for the Raven. I'm not quite sure how you do that off the phone app. But, we'll just confirm that, how you have it, set up for your program.
Mhm.
Perfect.
Okay,
We can keep going kind of more through the structures side of things. Oh, what did I do? There we
okay, can you go back to the picture? Let me just, I know I'm gonna see it, but,
See if I
blow
can
it up
zoom
as
in
much
there.
as you can, and let me just take a quick look.
Bob, do you mind help me? I don't use this track that much.
Yes.
Okay, yeah, okay. And so you have the 1 tube break there on the booster with the switch band, right?
Yeah.
Yep.
And is that the interstage coupler in black?
Yes, with the black tip on the right, upper right.
Okay. And then I see your wire conduit. And so I don't see a switch band for the sustainer. Is there one?
There is one. It's so if you kind of see, can you see our mouse?
Yeah.
Or-
Yeah,
It is right where this gray box is. It's unpainted, so it's a little bit hard to see.
okay. And are you gonna be routing both the uniter and the separation charge through that conduit?
Yep.
Okay,
Okay. So we can move on. Yeah, if you want more close-up pictures, upper airframe nose cone with recovery storage. Uh, these are just the fins. This is the upper fin can. The coupler, the booster motor overlap. There's the
now, why, go back to the booster motor? Is it gonna hang out that far?
Yes, sir.
Okay, just pork landing?
That's
Sure.
actually gonna be our main source of stabilization and support to hold the stages together before black powder staging. So this is what's gonna overlap with our airframe on the lower stage. And that main strength and stability is what's keeping the upper stage from wobbling, from having any instability issues as we light our booster.
Oh, okay, I saw the, upper stage booster, and I thought maybe that was the booster motor, but that's
Oh,
not.
I
That's
see, I
That's
see.
your sustainer motor, okay.
Yeah.
Okay, and I see you managed to get one with no, thrust ring on it. And so that's what you're gonna use for your staging coupler is the motor itself,
Yes, sir.
okay.
This is the black powder staging bulkhead and charge well. And these are just some concepts that we tried. We tried a
We
lot of.
tried a few staging concepts before we
Yeah.
resulted on black powder. And fortunately, black powder works significantly better than the others did.
Yeah.
Okay, so you've tested stage separation with black powder?
Yes.
Mhm.
How much are you using?
We're using 1.5 grams right now. We've tested we tested like what's the phrase? Just like tested without we did ground testing with 5 and 1, and we've done 2 launches with 1.5 to verify that it stages correctly.
You mean 0.5, right?
Well,
Oh, that's 0.5.
so yeah, sorry, 0.5 and 1, and then sorry.
Yeah, I was gonna say the typical amount is somewhere between 0.5 and 1.
Okay.
And if you go much above that, you basically just end up frying the wires more than anything else. So blow that picture up just a little bit. Okay, so the nose cone is on the left, right? Or I'm sorry, no, the nose cone's on the right.
Yeah.
And we're looking at the upper altimeter base. So you're gonna connect whatever, I'm not sure what you call that fitting there
The
for the
gray
wires.
Oh yeah, this is the raceway, is what we call it.
Okay, we'll go on. I'm a little curious on some of the components on the bulkhead there, but you can show me that later.
Yeah. Okay, so, oh, the bulkhead.
You want to show how you connect the igniter and the. Yes. So we have so at both the top and the bottom of our like raceway conduit, we have Wago lever connectors in order to be able to quickly like plug in and plug in our E-matches essentially, both at the bottom and at the top.
Okay, are those like spring-loaded clips or something like that, or?
Yeah, so the orange part like levers up and then you can shove the wire into them and they hold on pretty tight. Usually the wire breaks before the connection does.
Okay,
Yeah, so the bulkhead configuration, and this is the recovery layout.
okay, are you gonna be able to show me the pieces of that?
Yes,
Okay, all right,
the pieces of the bulkhead.
or of the recovery system.
Oh, like this?
Yeah, I mean, to actually show me,
Oh, yeah, we have them.
yeah, okay. Yeah, that'd probably be better than trying to decipher this.
Okay, got it. But yeah, and then this is the concept of
Yeah,
operation.
let me just check that real quick. So, the concept drawing.
Oh, the concept.
Yeah, so let's see. So currently on the booster, you're showing the drogue in the middle and the main is on top of that. And then on the sustainer, the same thing, I think.
Mhm.
Yeah, okay.
Oh, here.
Okay. Now, okay, now this is, which is this, the topper, the booster, sustainer, or both essentially?
They're both
This
the
this would be the same for all of our AV bay lids.
Okay, so you're gonna have the lid on there and then, what, a couple of, rods that hold the bay together?
Mhm.
Mhm.
And then how big are those?
Are the rods?
Yeah,
So the rods are our threaded rods are 12 inches long.
okay, what diameter are they?
Quarter 20.
Okay, yeah, on some other reviews, I'm kind of recommending that people go with like 5/16 on those. Um, for the sizes of the rockets. Now, yours is 4 inch, so I guess I'm not too worried about that. On another team, it was a 6 inch. rocket, and they were kind of doing the same thing. And, you start worrying about the, the harness kind of making maybe sort of an asymmetrical tug on the lid. And, then the rods, you can kind of imagine they're maybe not as strong as you'd like. For 4-inch, I'm not quite as worried about that. I would suggest, one of the things that I want to accomplish in this review is just to make sure that if someone else does the on-site review, that they don't see something that they object to and make you go off and do a remediation, because it's a lot more difficult to do it on site than it is, back in school.
Mhm.
I'll just point out the possibility that someone might object to the 1/4 inch. I kind of doubt it, but I would just offer the recommendation, if it's something that's very easy for you to change, you might consider doing that. But the 1/4 inch should be okay.
Okay, got it.
Now, you're going to be the 30K, so you do have to consider the effect of the of the altitude on your sustainer drogue charges,
Mhm.
right? Do you know what I'm talking about?
Yeah, yep,
So,
there's less air, and it is more difficult to light black powder at those altitudes. Is that what you're referring to?
yeah, it starts to matter when you get to 30K. Sort of the threshold for a concern about that is maybe 20K. And so when you get to 30K, you need to do something to make sure that you will have enough energy to separate the sections. So with some of the things you might do are to fully contain the top of the charge, like with electrical tape or something, multiple layers, so that you will build up a little back pressure in the charge before it ruptures that tape and everything escapes. So with the wire hanging over the top, that can be a little bit more difficult to do that. What I would do in the situation that you have here is you might consider making a little notch in the edge of the cylinder so that the wire could lay flush. And that way you can, maybe it might be a little bit easier to seal everything up if you don't have the wire that you're trying to get around.
Okay.
Yeah, it's
That makes sense?
yeah, it's a little bit tricky to describe, but I would say that so the caps that we use for these we've toleranced them quite tight on there, so they actually are also kind of difficult to get on in the first place, but we found that does actually help with our containment.
Okay, so you have a cap that you're going to put on here and it just goes over the wire?
Yeah, so the wire actually sticks through the cap. It's little, so the cap is like shoved into the container. It's printed out of like a flex filament. If you're familiar with like Aerotech, like DMS motors, how they have the little red cap the charge well, it's similar to that, but significantly tighter.
Okay.
And designed for the E-match to stick through it. And we've been flying this for a couple years now. And we have flown it on a previous 30K flight.
Okay. Yeah, that sounds like it would help. If it's, as long as it's reasonably tight on there. And there's really not even a problem with adding a little bit more containment to it. You're not gonna, it's hard to imagine you would go too far.
Yeah.
With something that wouldn't come apart. and providing that back pressure is important. The other thing that you want to do is have the E-match head be right at the top of the black powder
Yeah,
and not
so
down at the bottom of the charge.
yeah, that was kind of the intent with the sticking the E-match wire through the cap, so it could be at the top of the charge.
Okay. And then the last thing I would suggest is that, you know, so if you're going to be doing ground testing or whatever, that you can kind of, you know, once you get all the wires installed there, it can be helpful to put, you know, some tape over the electrical connections just to isolate them from the black powder gases as best you can.
Yeah.
You know, so it's a little hard to envision it with the devices that you've got there, but if you can protect them a little bit, they'll last longer, and you're less likely to have you know, some problem develop after the fifth use where, you know, something is corroded and is not making contact as well as it did when it was new.
Mhm.
On the other side of the U-bolt, do you have the metal fitting that goes between the threaded rods on the U-bolt?
The plate, right?
I'm sorry?
The metal plate that comes with.
Yeah, these usually come with a little metal plate.
Yeah, yeah, we have that.
Okay. All right.
Okay. Oh yeah, this is the design.
Okay.
Yeah, I didn't insert the cap all the way in because there was no way I was getting it out without firing a charge.
And yeah, just the AV section, if you want to know, we have a timer quantum for the backup, SRAD, and then Blue Raven is the main COTS flight controller, featherweight GPS, and a mini switch for arming.
Okay. And have you flown the Quantum yet?
Yep.
Yeah.
Okay. Yeah, because they require a test flight. So you might have in hand with you for once you get the site, just to have a plot that shows the output of it.
Yeah.
You know, that just proves you flew it in a flight.
Oh yeah, we have data in our test reports.
Yeah.
And then yeah, this is just the PCB design.
Okay, so what batteries are going to go on there?
18650s.
Okay, and so you're gonna have two of them?
Yeah. Two
and-
for two for the backup side and one for the COTS side.
Okay,
Yeah. So this is how it's set up.
okay, so let's look at this for a minute. So this is your sustainer, so you have a you're gonna run the Blue Raven off one cell,
Yeah.
okay, and you have the switch to the igniter.
Mm-hmm.
And is that switch, are you interrupting one lead to the igniter?
I believe so.
Yeah.
Okay. Is that like a screw switch?
We use pin switches for all of our mechanical switches.
I'm sorry, the what switch?
Pin
Pin
switches.
switch.
I still miss that.
The one you pull.
Pin switches.
Oh, okay, pull pins, yeah, okay. Okay, so that's the Blue Raven. And then you have the egg timer. Now, the egg timer has the Wi-Fi switch, right?
So we have so per stage we have dual Wi-Fi switches. So the egg timer has the built-in Wi-Fi switch, and then we also have, it's not on the diagram.
Yeah, but we have the
Uh,
Wi-Fi switch for the Blue Raven. So
in between the
this is the Wi-Fi.
yeah,
switch.
in between the L ion and the switch for the 2S that should say 1S actually.
Yeah.
The switch for the 3.7 volt side and the Blue Raven is another independent Wi-Fi switch.
Okay, so you have now you say 2S, you have two of them wired in series?
Sorry, it's 1S.
That's 1S, okay. And the Wi-Fi switch you have is one that you assembled, the egg timer Wi-Fi switch?
Yeah.
Okay, and are you sure that it is the version that is compatible with a 1S battery?
Yes.
Yeah, we flew it.
Okay, but the question is, are you sure that it is the one that is compatible with 1S?
Oh yeah,
About 2 or 3 years ago, they switched or they upgraded the Wi-Fi switch to use 1S power. Prior to that, you could use 1S, but if the voltage dropped below about 3.7 or something, the Wi-Fi switch stopped working. And so they made a change in the Wi-Fi switch. So if you purchased it within the last year or two, it'll be okay for 1S. If it's one you've had laying around for 5 years, then you might want to check it and make sure that it actually is designed for 1S.
Okay, got it. Yeah, we'll check our version, and if it turns out that it needs 2S, we can easily reroute the wire to get from the 2S.
Or order another one.
Or get another one that's newer.
Yeah, I mean, there's a way that you can, I think you look at the part number on the board
Oh,
and you can tell from that. You might need to contact the manufacturer. If you're not sure about it, the best way is to contact them and make sure that it's compatible for the 1S.
okay, yeah, we'll do that.
Okay, so on this one, for the Blue Raven, what you're planning to do is turn the Wi-Fi switch on when the rocket is horizontal, right?
Yeah, so the
Yeah.
Wi-Fi switch will be on.
Okay, and then you're gonna power up the Blue Raven once it's vertical.
Yes, yeah.
And then for the egg timer, that also has a Wi-Fi switch built in?
Yeah.
Okay, and the rules don't actually allow you to turn that one on because the Wi-Fi switch is integral to the altimeter. But I'm gonna let you do it if you, as long as you do a ground test. You know, it's part of the all up test that you turn that on and verify that it works okay. So if you were using that for the sustainer igniter, I wouldn't let you do it. But since it's just for the black powder charges, you can turn that one on the ground
Mm.
and then arm it when it's vertical.
Okay, thank you so much.
Okay,
And yeah, this is the booster stage.
okay, and is that again a 1S for
Yeah,
the
it's 1S.
for both?
Just for the Blue Raven side.
Yeah.
Okay, so here the Blue Raven is 1S, but the egg timer is 2S?
Yeah. Egg timer is 2S and Blue Raven is 1S.
Okay. And was that the same on the sustainer? The egg timer is also 2S?
Yeah, basically the it's both the same for the upper and lower AV.
Okay, and so you're just wiring the batteries in series then to get that voltage.
Oh yeah.
Okay, all right.
All right. Yeah, this is the actual board.
Now, how are you gonna constrain the batteries in the battery holders?
We have this casing that we screw in.
Okay,
And then we also have a casing on the other side.
Okay, and let me look at those, let me look at this for just a second.
Mhm.
What are the white rectangles right in the middle? Is that the battery connector?
Those are our pin switches, or pull pin.
Ah, okay, all right. Now, I think I saw some mention that you wanted to remove the pull pin switch for the igniter when you were horizontal.
So
Yeah.
I think I read that you want, so I think that what you're saying is that you would turn on the Blue Raven horizontal and pull the pull pin for the igniter while horizontal.
So when we pull the pull pin, the Blue Raven will still be off, but then once it's vertical, we're gonna turn on the Blue Raven through the Wi-Fi switch.
Okay,
Yeah.
but you can't pull the pin until it's vertical,
the pin for the igniter.
right?
Okay.
Okay, then we can tie a string and pull it up. when it's
Yeah, you just have to be able to be vertical when that pin is pulled out.
Okay,
And then you also have to be able to reinsert it if you need to.
okay.
Okay. Okay. Oh, back up a second. Now, what material are those 1/4-inch rods made out of?
It's black oxide coated steel, I think.
Okay,
I don't know the coatings, but I know it's steel.
all right. They're not nylon threaded,
They're steel.
which look the same as those. Okay, so you would have um, why is there a fitting? They're right at the top of both bays. It looks like there's a hex fitting.
This
That
is from the U.
No, not that. I'm talking about the 1/4-inch rod. It looks like there's a hex fitting there. The
This one?
Yeah,
Oh, this is to mount the AV bay, the AV PCB board.
okay, let me try one more time. Is the threaded rod continuous all the
Yeah.
way through the altimeter bay?
Yeah, it goes all the
It
way
goes-
through.
Oh, okay, so that's not a hex fitting, that is a hex nut.
Yeah,
Okay.
those are just nuts.
Okay, I got it, all right. Okay, and I see that. Okay, that looks fine.
Okay, thank you. So yeah, this is the same diagram. Yeah, that's basically most of our technical reports, and well, we have pictures that we can share screen.
Okay,
Do you have any other questions?
well, let me look down my list here and see what questions I have. And then we can look at the rocket. Let me see. Okay, one thing I'm gonna want to see on the sustainer, I think you mentioned there's an aluminum thrust block for that. So we'll just make a note to look at that, so that we're all confident that the motor thrust is not gonna let the motor fly through the rocket. And what size charges are you have you kind of decided the black powder amounts?
For recovery or staging?
The recovery.
Recovery. Hey, Matthew.
Matthew?
I think Matthew's getting.
Oh,
What's our black powder charge for recovery? What
There will
amount?
be a table in the report with all the sizes.
okay. It's like,
Yeah, I think I saw a slide that we passed that had it.
oh, yeah,
It wasn't quick enough.
you do. It's here.
Okay, and those look about right. Okay. Oh, the other thing I didn't mention on the charges is that, I mean, if you had a really well-contained charge, I mean, it, well, let me back up. When I fly really high altitude, I have a sort of an extended length charge container. It's just a brass tube. It's about 3 inches long. And the powder goes in the bottom 1 inch. And then the 2 inches above that is just literally open space.
Mm.
I might put some, some wadding in there or something, but basically it's empty. And then what happens is when the, even at high altitude, when you ignite the charge, a little bit of the black powder burns and it builds up some back pressure. And that lets a little bit more black powder burn and it builds up more pressure. And so on and so forth until all of the black powder burns very vigorously. It's like, I call it deployment by shotgun.
Mm.
And so if you think of a continuum, if you just have sort of a big charge and it's not contained very well, less of the black powder will burn. But then the farther you go towards a case where you've got what I just described, a greater and greater percentage of the black powder will burn. So if you had sort of an uncontained charge and it wasn't, you didn't have a lot of back pressure, what I would tell you is to increase the amount of black powder by about 30%.
Mm.
And to compensate for the altitude. And that 30% number gets lower and lower, the better the containment is.
Okay.
And then in the limit, where you use the kind of charge that I described, there's no difference between ground and 30K. So what you can think about is, do you want to raise the amount of black powder you're using by any amount to compensate for that altitude? And, my feeling is that if you were to use the plug that you've got there, and as I say, I might add a little bit of extra tape to that. I mean, you might think like 10% or something over the ground, but probably that would be enough.
Okay.
Okay.
So just some ideas there on the charge sizing.
Yeah.
I just mentioned it to people. I don't think it applies in your case, but the standoffs for the Raven are exposed to the electrical circuit, so they actually, I'm not sure if they're the positive side or the ground side, but they're actually part of the circuit for the Raven. That can get people into trouble if they are not careful. Or situations where, if, you can imagine having a problem because of that. So I just alert people that the Raven has that characteristic.
Okay.
The way you got it mounted on plastic, it's not going to matter. But just so you know it.
Yeah.
Oh, I guess I did look at the ejection charge tests. My opinion is that they were maybe a little bit more energetic than you want. the one that I saw, that was cooking pretty good. Um, I- maybe review that video and see if you really want to use as much as was in that video.
Okay.
Because that looked like it was, you want to get them apart, but you don't necessarily want to get them apart too fast.
Okay.
So what happened in your test flight that made you think about 10K instead of 30K?
So it basically like launched, and then I think it was because it was crazy windy that day at FAR, so it kind of over tilted, and then the stage separated, but the upper motor didn't ignite, and then in the landing it hit a rock, so we have to rebuild.
Oh, okay.
Yeah.
So why do you think that it didn't light?
Oh, we knew it was because in the Blue Raven, we put tilt angle at 60 degrees, so we checked the data, it didn't over tilt beyond that. It's just that I think our gyro angle parameter, we set it at 10 degrees, and I think it might have been too strict.
Okay.
Yeah.
Yeah, I mean, you on a 30K, I mean, I think the rules allow you to set it at 20 degrees.
Mm,
I tell teams to do some simulations to see
yeah.
how far the rocket will land if it indeed is at 20 degrees when the signal comes to light the sustainer. And then maybe decide if you really want to land 10 miles away or not.
Okay.
Uh, I would personally use 15 degrees. I'm not going to say you can't use 20 because I know everyone wants to get them lit and not get tilted out. But you can also kind of look at it and say, well, okay, if it's tilted that much, you're going to have a lot of horizontal velocity. And is the rocket going to survive deployment if you've got that much horizontal velocity because of that tilt?
Mm-hmm.
And so you start saying, if it really is at 20 degrees, do you really want it to light?
Yeah.
And sometimes the answer is no, depending on how you have it set up.
Okay.
But that's kind of your choice. I mean, I would personally pick 15, but 20 is in the rules. So if you want to do that, you can.
Actually, I also wanted to ask you a question if you know more about the Blue Ravens. So there's a tilt angle and a gyro angle. The tilt angle is default at 60. Do not ignite if it exceeds. But then the gyro angle, like the data I can get from Blue Raven is just the X, Y, and Z gyro. So like how is the angle calculated? It's just the norm?
Well, the one thing that I think the 60-degree reading is the reading that is used to determine. I think I'm not 100% sure about this, but I'm pretty sure that number is a number that it would be that if you ever exceeded 60 degrees, that would shut off the sustainer ignition for the flight.
Yeah, that's true.
But there's a second angle that
Yeah.
you put in that is the criteria for staging, and that would be the 15 or 20 degrees.
Yeah.
Right.
Yeah.
Now I'm not 100% sure if the Raven reports the angle or not. I mean, I would think that it does, but
It doesn't.
it doesn't report the tilt angle.
Like, it reports the tilt angle, but not the gyro angle.
Oh, okay.
And
Well,
yeah.
the tilt angle is calculated from the gyro readings, right? But you don't literally have I mean, there's a lot of math in there to
Okay.
go from gyro readings to orientation.
Okay, makes sense.
Because you can kind of imagine if you, I mean, let's say that the rocket's going up and you tilted 20 degrees in one direction. Okay, so one thing that might happen is that you tilt 20 degrees back again. Okay, and then you might say, okay, that gyro went at some rate in one direction and then it came back in the other direction. But if the rocket happened to roll 180 degrees, the coming back part would be in the opposite sign.
Okay.
So you can't look at just the gyro readings. You have to go through a process where you know, every time there's a reading that comes in, a new orientation is calculated based on all three of the gyros. And so you use quaternions or Euler angles or something like that
Okay.
to go ahead and do that calculation to figure out the orientation. So you don't necessarily really want the gyro readings, at least for the yaw and pitch. You know, I'm sure that it reads you the long axis, the roll angle, and you get the roll rates out of it. But the other gyro readings won't really be useful to you anyway.
Okay, makes sense. So in the rules, we can only set it maximum to 20, right?
Yeah, the rule for, well, you can have the 60 in there that shuts it off at 60.
Oh yeah, still.
There's another one that you can have that can be like 20.
Okay, noted.
And like I say, I'd recommend 15, but you can use 20 if you want. I always tell teams, you know, you can do a simulation where you know, the way that I do them is I change the launch angle until I get the tilt angle that I'm setting at the point where the igniter will light.
Okay.
And then once you do that, now look at what the rest of the flight looks like. What does it tell you is the horizontal velocity that you're going to be at apogee? What does it tell you? How far away are you at apogee? You know, and look at those things and just say, yeah, that's okay. If that happens, we're okay with, you know, 250 feet a second horizontal velocity, if that's what it was.
Okay.
And like I say, you might decide you don't really want to get to that situation. I mean, I've had flights where, you know, the rocket was at the 20 degrees, actually I had one where there was a mistake in the firmware for the Easy Mega. And it actually was at 19 degrees and it should have lit, but it didn't because there was this firmware problem. And I was actually quite glad that it didn't light because I know that if it lights at 19 degrees, I'm going to be 15 miles away.
Yeah.
I'm not going to be able to recover the rocket.
Yeah.
And so, you know, sometimes it's better not to light it than to have it light at a big angle.
Yeah.
So, you know, just consciously make that decision based on the data in a simulation where you can see what those things are going to be if you run the simulation that way.
Okay, noted. Thank you.
As far as the igniter goes, let me, I'm giving a little bit of advice to each team because I want to see sustainer motors light. One thing that's important is to make sure that the igniter stays in the motor when the igniter fires. And you know, if you were on the ground lighting motor, you know, are you planning to use like a stick for the igniter?
Yes, for I believe both the booster and the sustainer I know for certain the sustainer we're planning on using a stick and then like a motor cap to keep the stick in place.
Okay.
And for ignition.
Yeah, now if you were on the ground with the stick, you'd probably have the stick sticking out of the motor and you might tape it off against the rail or something like that so that the stick stays in. Right? Okay. Sustainer needs to be the same way. The cap is not enough to keep the igniter in the motor.
Okay.
A lot of people do that, but that's kind of what you don't want to do. You know, because when the igniter fires, it'll just blow the cap off and it'll, you know, the igniter will be right behind it. And so what you need to accomplish is to hold the igniter in the motor for just a couple milliseconds. And you know, for a very short time, and then the motor will light. If you let the stick start moving when it's lit, then you risk not lighting the motor. So the trick is to figure out how to hold the stick in, but not block the passageway through the nozzle for the gases from the igniter.
Okay.
Okay, so you might imagine taking a piece of electrical tape that's very narrow, maybe 1/4 inch wide or something. And you might hold the stick in with that piece of electrical tape and then tape up to the side of the nozzle. But I didn't describe that very well, but basically just have one side of the nozzle to the bottom of the stick to the other side of the nozzle.
I see what you're saying.
And so, you can even do that in 2 directions, so that you make an X. But in what I just described, though, you still have a lot of open passageway for the igniter gases to pass through. So
Okay.
that hold it in there, I mean, that electrical tape's gonna melt, but it'll hold it in there just long enough so that the igniter will light. And then you can still put the red cap on to block the core from your separation charge.
Mhm.
Okay,
That makes sense.
yeah, so, if you don't prevent that stick from flying out, you're about 50-50 on lighting the motor. If you hold it in there for just a second, your odds go up considerably.
Okay.
So what igniter are you gonna use for the sustainer?
We're gonna have to ask Matthew.
Matthew, what igniter are we using for sustainer?
We're using, so for our sustainer, we're using E-matches dipped in, Procast. That's my one.
A lot of alarms.
Sorry.
Did you?
Okay, so you're gonna use a dipped igniter,
Yes.
okay? And if you, let's see, your sustainer motor is an M1600. I mean, if you want to get tricky, you can figure out how to wire a second igniter head to the igniter. So that you have 2 E-matches basically instead of just one.
Okay.
And I'm not sure it matters if you wire them in parallel or series, but that if I'm trying to maximize the reliability of the igniter, the thing that goes wrong with igniters is that the E-match fires but doesn't light the Procast. So you can double your odds of, that's probably the limiting factor in getting the motor lit on a dipped E-match, is that you just blow the pyrogen off and it doesn't actually burn. So you can increase your odds a little bit by using an igniter that has 2 E-match heads, and then basically they both get covered by the dip.
Okay.
Okay.
On an M motor, I mean, if you want, you can just literally run 2 E-match wires up there and do it that way.
Okay.
But, people talk about wanting to use like 2 altimeters. Like, no, just use 1 altimeter,
Yeah.
but use 2 E-matches.
Makes sense.
Okay, so one of the things I wanted to look at on the rocket was the thrust transfer. I'm just gonna look down the rest of my list. Did you have the, we'll look at the rail buttons and where they're positioned.
Which, if you want to pull up the technical report, I can start just discussing it now, and then hopefully we did, because with the airframe situation, I think Matthew's trying to put it together, we de-integrated some of our hardware. But I can give you a kind of a decent run through of it right now.
Scroll up.
Yep, you can actually scroll back down. So we have, these are our rail buttons, the interview, if you want to scroll back up to this top picture. This is our test. Let me see if there's a better picture of where they're actually located. If you want to go to the actual entire view of the,
The rocket, right?
they're
Mm.
both on the booster stage. So if we scroll in a little bit, you can see them very slightly. There's the one here on the white.
Uh-huh,
Then the other one is down here on our fin can.
okay.
Those are our two rail buttons. They're through, and I can show you kind of how we created them. Are you seeing the rail buttons all right? This one specifically is kind of tough to see in the picture.
Yeah, yeah, I can see them.
Okay.
Now, one thing I noticed, I think, yeah, you were calculating, or in one of the reports, a rail velocity of 94 feet per second.
Yeah.
And so one question that I would ask you is when you calculated that number, well, let me say this. When you calculate that number, it should be at the time that that upper rail button leaves the rail.
Mhm.
Okay, so if that distance is 4 feet, for example, and maybe it's probably 3 to 4 feet, basically, instead of assuming a 17-foot rail, you would have to assume a 13-foot rail,
Mm.
I see.
right? So that, because you lose control at the point where that upper button leaves.
Yeah.
And so that's where the calculation of rail velocity needs to be.
Got it.
And with your rocket, it's, you know, reasonably heavy, right? And
Yeah.
you've got a N3300, which, you know, I mean, it's not an N5800, it's an N3300.
Mhm.
So that reduces your thrust a little bit and your rail velocity.
Yeah.
So I'm just gonna assume from your expressions that maybe your rail velocity is gonna go down once you do that calculation correctly, okay?
Okay.
So one thing that I would recommend, if you can figure out how to do it, is to have have that upper rail button. Well, let me say this. What I would recommend you do is to use 3 rail buttons.
Okay.
And the second rail button should be closer to the bottom of the rocket. Sort of the ideal spacing for that might be 18 to 24 inches. And so you don't lose quite as much of the effective rail, you know, when you get those lower buttons closer together.
That's 18 to 24 inches from the lowest rail button. Is that what you're
That's
referring?
correct.
Okay.
Yeah, and I mean, 18 is plenty fine. I mean, you know, if you showed up and you had the 2 lower rail buttons a foot apart and a third button higher up, that would be fine.
Mhm.
You know, so what you want to avoid is having the 2 lower buttons be too far apart. So, you know, they shouldn't be more than 2 feet. 18 is fine, and even a little less than 18 is fine. And then you have a third button higher up that kind of prevents you from torquing you know, torquing the lower 2 buttons.
Mhm.
You know, it's just sort of insurance, and you know that can be higher up on the airframe, and even where it's located now is fine.
Okay.
Okay.
And you know, you just have to make sure that all 3 of them are aligned, because you don't have a whole lot of tolerance on the 15-15 buttons. They tend to be a little bit tighter, so you have to be careful that they're aligned well.
Yeah.
Um, you know, typically on those buttons, I'll sand those buttons out a little bit so they're a little bit looser on the rail,
Mhm.
just because of that tolerance issue.
Okay.
Now, in one of the pictures, I saw what looked like a PML plastic rail button or rail guide. Are you using that?
No, so we're using, I don't particularly know the name of the hardware, but the circular wheel ones, which I can pull up another picture
Okay.
to make it very clear what I'm referring to. Um So I think what you're referring to in terms of the not PVC, but the PLA like 3D printed looking part is this. So
Yes.
this was mainly just so for our test. Because our motor is so big and the launch lugs are and the motor's like minimum diameter, we actually ran a test to integrate and manufacture the launch lugs such that they can still leave space for the motor while remaining strong and rigid. So this was just our test. We're not using this variation of like launch rail button. We're going to be
Okay,
using.
how are you clearing the motor with your buttons?
Sorry.
I mean, that's a good question to ask, since your minimum diameter, how are you securing those screws? Because having them only through one airframe section is not really a very strong connection.
I may have Matthew come in. He did most of our tests for this. Hey Matthew, can you come answer a quick question about the launch lugs?
He asked how do you make it stable when it's
Like
minimum
the
diameter?
strength when it's with our minimum diameter with the motor. So he's just kind of asking about this process, and
Did you show the test report?
I haven't brought up the test report not yet.
And part of it is in the test report.
Oh. Let's see.
Well, the question is, since your minimum diameter, how are you attaching the rail buttons so that they're secure enough? Because threading a rail button into a single thickness of airframe is not a very strong connection.
Yeah, so we use the we use the 1515 launch lugs from Apogee, which have the little like barrel thing with the low like metal piece that is supposed to go on the inside of the airframe.
Right.
And so,
But that's going to get in the way of the motor.
Which one?
well, the test report.
No, it's in structures.
Oh, in instructions.
Yeah.
Yeah, so
Mm.
we have the airframe kind of sanded down where that part goes. And that part of the airframe is where our layup for the fins are, so we increase our thickness by a good amount at that location. So we did testing on like how we mounted it. And confirmed that we were more scared of the airframe breaking than our attachment method breaking.
Well, yeah, I mean, yeah, whatever fails, it doesn't matter if it fails. You know, I mean, if you reduce the thickness of the airframe there, you might be you know, weakening that a little bit, but you know, at the same time, sometimes the motor has a little bit of wiggle room in the tube,
Yeah,
and you can get past it if it's not too tall. Okay. Yeah, I was just gonna say, I mean, you know, I don't really use single buttons on minimum diameter like that. And you know, that's something that well, I'm pretty sure that any reviewer is gonna look at that, and they're gonna wanna see that attachment pretty carefully. And they're gonna yank on those rail buttons and make sure that they're tight and they don't come out. So make sure that they're secure. And that there's, you know, no one looking at them.
Yeah.
Would conclude that they're not strong enough. That's another reason to go ahead and add a third button. Now, you'd have to do it down where the motor is again, you know, just like, you know, what you did on the low button. But I would recommend that you do that. As, you know, one more thing that you can say, you know, yeah, okay, we have this for the minimum diameter, but we have 3 of them on there, so that, you know, just to provide a little bit of insurance on the rail button security. I actually use on minimum diameter that plastic rail guide that you showed. And the reason for that is that, you know, you can glue them on and you've got two screws, even though they're not going in very far. So I don't like them at all. They're very brittle and easy to break, and you have to be very careful putting them on, but that's sort of the approach I take. So just make sure that, you know, that when a reviewer starts bending on that rail button, that it doesn't move. You know, there's no play in it at all. And go ahead and add the third button.
Okay.
Okay. All right, let's go look at the rocket real quick.
Let's,
Wait.
we gotta go grab some stuff, but
Let me bring this there.
yeah, go ahead.
Yeah, we don't have the full. We're currently in the stage of rebuilding the rocket, but we do have some.
But Jim was looking at the rocket. I'm gonna pull the airframes from the corner, sorry. A lot of it's de-integrated.
Okay, yeah, I mean,
So yeah, a lot of it is de-integrated because we are doing another test launch next 2 weeks actually. And we need to move all the parts and rebuild the rocket because it got damaged. Which part we can show you?
I think the part that he really wanted to see was our motor retainer
Okay,
and the thrust block.
it's not integrated in the rocket right now.
It's not integrated, but I could show him it. If he wants to see it. Matthew, do you know what it is?
No, y'all were the ones that de-integrated, I didn't do that.
Here's our current airframes. If you want to show them these, Isabel, I'll try and go get that thrust block for him.
okay. Yeah, so Max is getting the thrust blocks, but yeah, those are, yeah, we kind of damaged it on the route.
That one doesn't look good.
Yeah, yeah, no, yeah. Well, we literally just ordered new fiberglasses, and then our supplier also like they had some issues, but we expedited their shipping, so the new airframes should be here this week.
Okay, did you get that from Wildman?
Yeah. Wait, no. So now we got it from Mad Cow.
Okay, I think they're Wildman tubes, but you can get
Yeah.
them. Oh, okay, yeah, that's good because I know Wildman is suspended making the tubes.
Yeah, yeah, exactly. So yeah, that was really
Okay, but you were able to get one though.
Yeah, we did.
Okay, good.
Yeah, that was also part of the reason we're like, wait, should we just downgrade to 10K? Because like, yeah, because we do need another launch with the 2-stage. And then this is the other part of the
That's
motor.
the coupler of our booster. This is that black tip that you'd noticed before.
Yeah, let's just look down in there real quick if you can
Yeah, absolutely.
point that at the camera and let me just take. Okay, so is there a bulkhead inside of there or how are you?
So there will be a bulkhead right here.
Okay,
This will act as not only the black powder charge bulkhead with the charge well, but it'll also have the recovery bolt as well for the I forget which form of recovery, but basically for recovery as well.
okay, now where does that separate? Does it separate at all?
Okay, so this is where the motor's coming in. So the two stages will separate on this side, and then the other when it recovers will separate, and this is where the lower stage booster AV bay is down here. And so then it'll separate at this line with the AV bay, and then the other side of the AV bay then connects to this lower airframe with the motor in it, which is kind of what we were showing before.
Yeah.
Okay, but the connection is way up at the top for the recovery.
Yes, for from AV Bay to this piece. So there's
Okay,
I believe I think Maine's in the top for this one, right?
Yeah.
Yeah. So Maine will be in here connecting to the AV Bay and to this launch lug. Oh, if you will pop up. This-
okay.
Or sorry, not launch lug. My apologies. Bad turn phrase. This bulkhead.
Okay. And what size screws are going through there?
I believe we're using 832s, right? Yeah, we're using 832s.
Okay.
Yeah.
I always get concerned when I see connections like that where it is the shank of the screw that is what's making the connection with the airframe.
Mm.
You can kind of imagine the narrow diameter shank is kind of easy, somewhat easier to pull out than, just because it's so small.
Mm.
And I have a fitting approach that I use where I use socket screws instead of screws.
Okay.
And a socket screw is it has a larger diameter head. You know what those look like?
I believe
Yeah,
so.
there are, like, if you see any of our M3 hardware, it looks like that.
Okay. Yeah, yeah.
And the nice thing about that connection technique is that it distributes the force over the larger head of the socket screw rather than the narrower shank of the screw.
Okay.
And so I've made about 300 of those connections over time, and they're very strong and stuff doesn't tear out. And so I'm just going to send you a picture of what that looks like.
That'd be
And if you
fantastic.
wanted to, you could, it's pretty easy to go ahead and modify bulkheads to,
Right.
where you just drill a larger hole through the tube and through the bulkhead, and then screw in the socket screw. It tends to be a stronger connection. So I'll just offer that as a technique that I've had a lot of success with over time. And if you wanted to borrow it, you could certainly do that.
Okay,
Thank you.
thank you.
The thrust block. So similarly, this is the thrust block that's going on motor. Let me see if I have that here. So there's two sets of 6 screws on the top and then one on the bottom, alternating. This is kind of what it looks like.
Okay. And so let's see now, this is also minimum diameter, right?
Yes.
So you're going to be pushing on the bottom of that.
Yes, sir.
Right. Okay. And there must be a bulkhead or something associated with that. I mean, if you're going to retain the motor, there's got to be something.
So this is yeah, oh yes, there is a bulkhead then that sits above this.
Okay.
They're not pressed against or anything like that. It's there's I think a slight gap in between.
Okay, and then that's you would have a recovery point attached to that bulkhead.
Yes, I believe so.
Okay. That brings up a topic. Now I think as I recall on the altimeter bay lids, you had U-bolts, right?
Yes.
Okay. How are you connecting to the motors? What is that connection to the motor itself?
I believe it's a threaded rod. Right, Matthew, how are we connecting the motors?
Like for positive retention, or sorry, for negative retention.
I believe so. Yeah.
Well, yeah, so our bulkheads have threaded rods on them. So the whole thing is kind of like Thrust block floats is somewhere here on the airframe, and then our bulkhead is here. I don't know if it's the best way to show it, but
Lighting's not.
yeah. Bulkhead's
Okay, well, what holds that bulkhead in place?
also radial bolts.
Okay, I guess I don't see the holes.
Yeah, they're in this black part right here. It's like really hard to
Okay.
see.
All
Yeah.
right. And then, so what fitting gets attached to the top of that bulkhead? Is it an eye bolt or something?
So I actually at the top of this bulkhead doesn't have a U-bolt for recovery because on the sustainer we have let's see, because the payload is in between the recovery bay and the motor on the sustainer. So this is just blank at the top. We have a nut here, and then this part in the middle actually has threads built into it, additional threads. There's a nut that's sandwiched between these two G12 plates.
Okay, the question I'm getting at is, you're gonna have a harness attached to a fitting. And how do you prevent that fitting from unscrewing? Does that question make sense?
Yeah, so like you're saying, like if the motor is attached to here, if I'm just
Right.
twisting, it's gonna unscrew, right? That's kind of
Well, I mean, the scenario is that you
If-
have harness attached to the top of it somehow. And that harness, if the rockets start spinning, the harness will, could unscrew whatever fitting is on top of there. I mean, it could unscrew it from the motor or, depending on how it's configured. So the question is, how do you keep it from unscrewing?
which harness is
I
here?
think he was talking about, I had said originally that I thought there was a U-bolt for recovery, but I didn't realize that this was their payload in between.
Oh yeah,
So I think in this
there's
situation, this is actually not being used for recovery and purely just for motor retention. And so I must have misspoke earlier when I'd said that this is both for recovery and motor retention. And I believe this bulkhead is primarily just for motor retention, and then we'll have the payload, and then we have our recovery bulkhead. Is that correct?
Yeah.
Okay.
Okay, if it's just for motor retention, it's sort of unlikely that it's gonna unscrew.
Mhm.
But then the next question becomes, wherever the harness is attached. I mean, if it's a U-bolt, then there's not an issue, but if it's an eye nut, for example.
it's a U-bolt.
Okay, all right, okay. I would suggest considering the socket screw approach for the thrust plate as well. It's another place where,
Okay.
I mean, it's very difficult to look at it as a reviewer and say, oh, okay, well, 3 bolts or, 3 screws is enough, or 6 screws is enough. Or, how many is enough so that it won't tear out the fiberglass, from the motor thrust. And I don't know the answer to that question. And it's hard to calculate because you've got a, small shanks of a screw, up against fiberglass, and it's difficult to do an analysis of that. And, unless you actually test it, and you go in and you got 4 screws and you try to pull them out and you say, well, okay, where does it fail? Unless you do that, it's hard to answer the question, do you have enough?
Right.
So, you can, if you don't have that answer, then, it's not a bad idea to do things that basically convince a reviewer that, yep, it is strong enough. And the socket screws can help in that respect because you can say, okay, I don't have this narrow little screw shank. I have this socket head that's 3 times the diameter of that.
Right.
So it's harder for to pull the tube and, through it.
Mhm.
That would be another place where it's useful to do that.
Okay. Perfect.
Okay,
Thank you.
thank you for the suggestion.
So I think that should be okay, though. I mean, you've got 2 layers on there and, I mean, it looks to me like it should be okay. Um, And then let's see, I have to stop and think. It's funny this year, there's not that many minimum diameter two-stagers. Most of them are like 6 inches. So I have to stop and think, okay, minimum diameter, which I know all about, but it's just I have to stop and think about it in terms of your project. So, are your fins nice and strong?
Yes, sir.
They are, all right.
Pull those up. We're remanufacturing them right now, but we have a fiberglass. I think you can kind of see the inner line. I think actually we painted over it. We do a bead bond on a fiberglass sheet, 1/8 inch, fillet with Proline, and then we do 3 layers of carbon fiber over top, cut sand, kind of make it look nice. Make sure it's all I think the word's laminate, but I don't know if that's the correct word.
Yeah.
Yeah, so my suspicion is that that's probably plenty strong. My only comment is that when I do that, I make a larger radius fillet.
Okay.
And the details of that is it might be like maybe I'd make that with like a 1 1/4 inch dowel, 1 1/8 inch or 1 1/4 inch, held at about a 30-degree angle, something like that. And my guess is that you probably used something smaller to form the fillets. And the reason for that's pretty obvious. I mean, you don't want to have sharp angles or whatever with the carbon fiber. You're going to get the better strength if it's sort of, a little larger radius through the fillets. So that's sort of my only comment. I think otherwise it looks fine.
Perfect. Awesome. Thank you so much. Here, we're kind of. Do you have any other questions or anything else you might want to see?
Let's take a quick look at one of the recovery harnesses and the chute attachments.
Matthew, recovery harnesses.
Yeah, it's all.
Yeah.
So these are kind of put together right now. You need multimeter? Probably not. So recovery harnesses, we bought them from we bought them from Bad Hawk.
Okay.
I believe, yeah. They're all 25 footers. So, well, except for the one in the nose cone, but these are 25 feet in the middle.
Is that what he calls the 1/2 inch material?
I think it's either half or 5/8, I recall.
Okay, do you recall the rating of it?
I would have to pull up the order that I made. Do you want me to do that, or?
You don't have to do it right now, though. Put it up against the camera and let me kind of look at it and just make sure that,
So this is a 5/16 a quick link for reference.
yeah, if I had to guess, that sort of looks like the 3/8 material to me. But you should check that and, for several reasons. The one thing, the reviewer is going to say, tell me about your harness. And so you need to be able to say, okay, this is 3/8 or whatever it is from one Bad Hawk, and it has a rating of X pounds.
Yep.
And then the next question you need to be able to answer is if you have knots in the shock cord, which I think you do, you need to be able to quote how much that knot reduces the strength of the harness. And so you can look online and you can see, well, if it's a square knot, it does this. If it's a bowline, it does this. If it's a water knot, it does this. And typically it'll be something like a 30% derate in the strength of the harness.
Gotcha.
And so you know, what you need to be prepared to say is that we have harness that's rated for 3,000 and we have these kind of knots, and so that's going to derate it by X, and so the strength that we end up with on the harness is Y.
Mhm.
You need to be prepared to say that
Gotcha. Okay,
when the time comes.
sounds good.
Okay, so how long are the drogue harnesses?
So the drogue harnesses are 25 feet. Then, oh, go ahead.
So you got them from one bad hawk. Do they have like the third loop on them, or did you tie a knot for the drogue?
I tied a knot for the drogue.
Okay, and is it, I assume it's not located in the center, it's off to
It's 8 feet down on a 25-foot harness. So
the, okay, so about a third of the way, okay.
Yep.
Yeah, yeah, the 25 foot, if it's from one bad hawk, that sort of suggests that maybe it's the 3/8. If you, although actually, I'm not sure about that. If you don't get the third loop, they're typically 20 or 25 feet. If you get the third loop, they're 30.
Mhm. Yeah, the third loop ones are 35, if I recall.
Okay. Yeah, you might get some pushback on the 25-foot length.
Hmm.
I sat in on a review for a team where I'm the FOR, and the reviewer was adamant that they needed 5 times the length of the rocket.
Hmm.
So if you did that, let's see, you're what?
Yeah, each of our stages is about 7 feet each. So that would be 45 feet.
Well, 7 times 5, 35.
35 feet.
So there are some reviewers that would tell you that 25 feet is not long enough for the drogue.
Mhm.
So you might end up taking a trip over to the vendor and having to buy a longer one.
Yeah.
I'd say your odds of being asked to do that are probably about 50-50.
Okay.
You might mitigate that issue by getting a 35-foot now,
Mhm.
so that you're not put in that situation. Now,
That makes sense.
the mitigating thing, though, is that your payload is not at the top of the rocket in the cone, it's in the middle, right?
Mhm.
So there's, one of the reasons you use a longer shot cord is so that you have a less of a jerk when the drogue catches.
Mhm.
And you're trying to minimize that jerk because you don't want the main to come out.
Right.
So, if you have the payload up at the top, it makes it harder to keep the main from coming out because you got all that extra weight up
Mhm.
there. So you don't have that. You have the weight in the middle of the rocket
Yeah.
rather than the top. So in theory, that would allow you to go with a shorter shot cord for for that part of it. Yeah, when I just look at it, like I say, I mean, I think even with that consideration, you're likely to run into a reviewer that says that you need a longer cord there. So if you were able to do so, you might consider getting a 35-foot one.
Okay.
And you could also get the 3-loop style so that you don't have knots in the cord.
Mhm.
And check the size that you've got there. I don't have the one bad hawk memorized off the top of my head, but that kind of looks to me like the 3/8. And so if you take the 3/8 and you put a knot in there, you're starting to get a little bit marginal on the strength.
Mhm.
You would become more bulletproof if you had 35 foot with a 3 loop.
Gotcha.
I hate the 3rd loop on these things because it's like it doubles the thickness of the shot cord for, about 8 inches or something.
Yeah.
It makes it hard to pack in a minimum diameter because it's hard to fold it in half in there. So, I don't like them for that reason, but it's probably the lesser of the evils. If you can, if you've got enough room where you can put the 3rd loop in there, you'll satisfy the safety review more easily.
Okay. Sounds good.
So I'd try that for both stages. It's probably more important for the upper stage than the lower stage, but I would consider it for the upper stage.
Yeah, if we do that, we'll look into that and we'll probably do it for both stages just because we'd like to have for the drogues on both, we want to have as similar a design as possible for both stages for the drogue chamber. It just makes it easier for us to have spare parts.
Okay.
Yeah.
Now, the one thing, the other piece of advice I would have, if you go back to One Bad Hawk to do that, is that if you just buy the stock 3rd loop, it's actually located only like about 5 feet from one end,
Right.
which is a crappy location. I mean, it needs to be at the 1/3 location. So if you're able to do it, I would order them custom where you put the 3rd loop in the 1/3 position.
Okay.
And the guy that runs One Bad Hawk, Teddy, does not agree with that placement, even though the rest of the world, that's where they put them. So you just have to say, Teddy, we want the loop to be 1/3 of the way between the ends.
Hmm.
And maybe if enough teams do that, someday he'll make them that way. But as it is, he tends to put them very close to one end, which is not really what you want. So anyway, my advice on harnesses.
Okay.
Run through maybe what are the chute sizes that you're using, the style and size.
Yeah, so both of our drogues are 24-inch drogues. So our drogues are X-form chutes that we got from Top Flight Recovery. So they're shaped like an X.
Okay.
I don't know if you had anything on that.
No, I'm okay with those. They have the thicker shroud lines on them, and I think they'll be fine.
Yeah, we went with those just in case. These are, in theory, ballistic chutes. Who knows if they'll actually survive ballistic or not, but in theory, these are rated. So these are advertised as being able to handle higher deployment speeds just in case we need. So that's why we went with those. They don't pack as tight as other chutes, but we found that to be an okay sacrifice for drogue. And they're both 24-inch chutes for upper and lower stages. As we have pretty similar dry masses during descent.
Okay. And do you know roughly what speeds you're getting from those?
I don't have them on the top of my head, but they are in the technical report and they are within like the specified ranges. I think we went on the low end of the range for drogue speeds just because we analyzed the case that we don't light the sustainer motor, and which would mean we would land heavier, and that's why we chose for a lower descent speed on drogue, so that in case that happens, I believe we were still within like the maximum allowed descent rate on drogue, even if the motor didn't light on the sustainer.
Yeah, the maximum speed on drogue is very high.
Yeah, I think it was like
56.
what we were around. I think we were around like 105, 110-ish if the sustainer didn't light. for feet per second.
All right, that's okay.
Yeah.
Okay, and then your mains,
Both of our mains, so we have both of our mains are 7-foot toroidals that we got from Fruity Shoots.
Right.
Do you want to see the shoot or?
no, that's okay, and you're just going to, put a Nomex blanket around them,
Yep.
okay?
Yeah.
Yeah, I guess, you know, I'm a big proponent of using a deployment bag.
Mm-hmm.
And, you know, I would recommend for future rockets that you use them. Because once you start, and how big are those chutes, the toroidal ones?
7 feet.
7 feet, so 84 inches.
Yep.
Yeah, once you get that big, you really need to start thinking about organizing the deployment.
Hmm.
You know, I mean, what people do is they fly smaller rockets and put chutes out, and then they just continue to do that as the rocket gets larger. And at some point in time, all of a sudden, it stops working because the chutes are just too large. And if you don't arrange for them, you know, what you really want to do with a larger chute is to have a situation where you're pulling the shroud lines downward vertically. And then you pull the chute out of the bag, and then the chute opens where the shroud lines are already extended, and the orientation of the chute is vertical. If you just pull the chute out, like out of the nose cone as you're doing, you have sort of a fog of chute.
Hmm.
You know, the shroud lines aren't pulled, you know, nothing is organized. You're just throwing it out there. And at some point in time, as you increase the size, that stops working. And so I recommend looking at deployment bags, and there's a lot of different ways to use deployment bags.
Mm.
And you know, you're looking for organization of the chute as being one objective. Another objective for some designs can be to delay the opening of the chute a little, you know, until like the chute gets above some of the other parts. You know, that's another use of deployment bags. But I would just say as a team, that might be an area to look into in the future as you go along, because it will improve the reliability of your deployments.
Okay. That's good.
So how is show me the connection of the main to the harness.
So all of our mains are also connected similar to the drogue. So we have on the shock cord. So our mains are attached via, so there's a knot on the shock cord. We have a swivel tied into the knot, and then we have a quick link attaching to main.
Okay, and the rating of that swivel is probably what, 1500?
Yeah, 1500.
Okay. Yeah, you know, again, if you had a third loop shock cord there, you'd probably be a little bit safer.
Mhm.
And what I would say, you know, I mean, I'm not saying you can't continue to use them, because you could. But you know, if that harness rating is, you know, is less than, I mean, I'm gonna say if it's less than 3,000, then you might have an issue, because your knot's gonna derate you to 2,000.
Right.
And now you're sort of marginal. You
Mhm.
know, harness with 6,000, you're derating to 4,000, then I think you're probably okay.
Gotcha.
So, you know, check and see what harness you actually got, and then consider the knot, and then go from there.
Mhm. Makes sense.
Yeah, because you want to have all your harnesses figured out before you get to Spaceport, because otherwise you're going to end up going and buying one, and then the third loop's not going to be in the right spot, and you know. Although for the main, the third loop located close to the nose cone wouldn't be all that bad.
Yeah.
You know, it's mainly the drogue where it's more of an issue on the placement.
Mhm.
Okay, do you have any questions on the recovery stuff?
I don't believe I have any on my end. Yeah, thank you.
Okay, do you guys have any other questions?
Max, do we have any other questions?
No, I'm doing pretty good.
Yeah, I think we're good.
Okay, one thing to kind of keep in mind, and I put this into an email, but do everything you can to be prepared to fly early in the morning.
Yeah.
And you know, a little bit of the backstory on that is last year there was a lot of wind in the afternoon, and you know they had so many rockets to fly that they launched some of them when the wind was probably higher than they should have. And so there were some rockets that strayed and weathercocked badly, and you know the Tripoli management was there and they were not happy with the wind velocities at the time, and the spaceport people weren't happy, and so they actually had to go through and do an extensive analysis this year, looking at ballistic recovery locations and which way did the pads have to be aimed and how much wind, you know, where would they go with this much wind or this much more wind or whatever. And it was a lot of work for ESRA to be even able to fly to 30,000 feet. And so there's going to be a lot more eyes on launch conditions this year than there was last year, and they're not going to be able to launch rockets when the wind gets up to a certain amount.
Okay.
So the teams need to be prepared to launch in the morning before the wind comes up and as early as possible. And you know, I've probably launched 25 two-stage rockets out there. Every single team has told me, oh yeah, we're going to be there 7 in the morning on the first day, ready to launch. And to this day, no one ever has.
Okay.
And so everyone thinks they can do it, but they can't really do it because they're not prepared.
Okay.
And problems that you can run into or delays getting into Spaceport, they have traffic jams out there. And I think one of the things they're going to do this year is they may allow a few members of the two-stage teams to stay out at Spaceport overnight so that they can begin preparations a little earlier. And so you might want to think about that. I mean, I'm not sure I've heard a final verdict on that one, but
Okay.
at least that was what they were talking about, the two-stage teams and the hybrid teams being able to be out there so they could get an earlier start in the morning. So, you know, and that's because they want the two-stage and the hybrids to fly when there's no wind. You know, hybrids have low thrust to weight ratio, so that's why they want to fly them in no wind. And the two-stagers can have more, you know, more directional difficulties on the sustainer, let's just say. So they want you to fly early. And so the thing to do is to have a checklist that is thorough enough so that you're literally every step that you need to accomplish is on that checklist.
Yeah.
When I put together a checklist, it is thorough enough to where when I set up the rocket and prepare it for launch, I don't even think about what I'm doing. I just execute the checklist. And there was a fellow on the team at one point who said, well, Jim, can I do this? And it just shut me down because I have to stop and think about where that step is that he wants to do out of order is. It's like, don't tell me to do a step out of order. I'm going to follow exactly this order. And I've thought it through enough so that everything I need to do and every tool that I need and every piece of hardware that I need, I know I have, because I'm just going to follow the checklist and I know what I need for each step.
Okay.
And the other thing you can do is, you know, another really common problem is that, well, we're out here, we're ready to go, but, you know, John has the shear pins, you know, or, you know, Bill has the flight computer for the Raven. and he's not here yet. He's stuck in Las Cruces, and so we can't go. Those kind of things where you delegate steps to team members, you need not to have that step interfere with your ability to launch the rocket.
Makes sense.
So think about who's got the critical components and make sure they are there.
Yeah.
So you're not running into that problem.
Mm.
Because if teams, you know, if you have difficulties in getting set up, I mean, there's a real risk this year that of teams not being able to launch. So, you know, there's, if they have the wind like last year, I mean, you can go through the math and you can say, okay, we have, you know, 3 days and, you know, we're losing time in the morning. And so we've only got 3 hours a day that we can launch rockets over 4 days. So that's 12 hours. You got to launch 120 rockets in 12 hours. It's, you know, at some point in time, the math becomes untenable and you can't launch them. So don't run into that situation. Do more preparation on the timing than you might otherwise think is necessary.
Okay, yeah, we'll do that.
And unlike the single stage pads, you can spend a little bit more time prepping out at the 2-stage pad.
Okay.
To do things like igniters and to do an all-up test and, you know, things like that. So it's not like, you know, at the single stage pad where everyone goes out at once and, you know, you have to hurry up and get everything set up and then everyone leaves. You know, at the 2-stage pads, we have like maybe 12 of them. So there's a little bit more opportunity to be out there to do those steps than you otherwise would have on the single stage. So you can kind of consider that as well in your planning, but do everything you can so that you actually can get out there and launch the rocket within 2 hours of the time that you arrive. Because otherwise we run into this wind and there's going to be a lot of eyes on it this year. So I want everyone to be able to launch. And the key is going to be to be able to do it before noontime. You know, the earlier that you can do it, the better that it will be, not only for your flight, but, you know, just to ensure that you can fly. You know, you get a better flight if there's no wind. You know, so you want really focus on that aspect of it.
Okay.
Okay, thank you for the suggestion.
Okay, well, I don't have anything else. I'm
Okay.
gonna send you a picture on the socket screws.
Yep.
Yeah.
And other than that, I'll plan to see you out there.
Sounds
Okay,
great.
thank you so much.
Thank
I'll
you.
save the recording
Yeah.
and send it to Ezra.
Okay, have a good one.
Awesome,
Thanks,
thank you so
you too.
much. Have a great weekend.
Bye.
Bye.